Hello, my name is Sabrina Bocek, and this is Conservation Physiology, assessing humpback cortisol levels to monitor critical habitats. Non-invasive monitoring of wildlife populations' health using biomarkers such as hormones. These can all be extracted from feces, blowhole breath collected with drones, or blubber biopsies. Cortisol is classified as a stress hormone in mammals, produced by the adrenal cortex to regulate metabolism and respond to fight or flight energy needs. Baseline establishment for future correlation assessments to help prepare for critical habitat changes, such as warmer temperatures and higher latitudes, increases in vessel traffic, prey availability, chemical pollutants, noise disturbances, and disease. This study observed cortisol levels in humpback whales during the feeding season in the western Antarctic Peninsula for 3 years during COVID. Humpback whales have some of the longest migration routes. In this study, we will be looking at the populations that come to feed in the western Antarctic Peninsula, which come from both sides of South America and from Australia, and also some from the tip of Africa. "305 biopsies were taken around the peninsula of Antarctica using a crossbow with a stainless steel cutter shot just below the dorsal fin of the humpback whale using UC Santa Cruz's Institutional Animal Care and Use Committee approved protocols for the collection of whale biopsy samples. My hypothesis is that humpback whale cortisol levels will be at their highest at the beginning of the feeding season in January and February, and then be significantly diminished by March when they are ready to go, when they have met all their energy requirements nutritionally again. The hypothesis was accepted with a p-value of 0.006531. We can see in this graph that by March the cortisol levels had significantly dropped. Future directions for using biomarkers in conservation physiology. Conservation physiology helps us to monitor population dynamics with ongoing global shifts like sea temperatures rising, increases in anthropogenic disturbances, prey scarcity, habitat loss, possible implementation to help other marine mammals. For instance, right now in the United States of America, we have 2 simultaneous ongoing unusual mortality events happening on the east and west coast of the continent, with significant losses of baleen species. We have the scientific methods now to extract the environmental history from deceased whales' baleen plates, just like we would from tree rings, annual rings, to assess the environment then. The difference with conservation physiology is using the hormones that we are monitoring now to help see the trends if we need to come in and help protect these habitats and create policy changes before these animals become extinct, or to help replenish and grow endangered populations. Here's my literature cited, and I'd like to thank Dr. Bibles for helping me with my data analysis here at Unity College and my fellow classmates. Thank you.